Today topic is matrix chain multiplication, simply called as MCM. So this matrix chain multiplication using the algorithm design, programming design technique called a dynamic programming. Okay, what is the goal? Find the most efficient way to parenthesis a chain of matrices so that the total number of scalar multiplication is minimum. Okay, these given matrices are there. Here we want to multiple four matrices a1, a2, a3, a4. Okay, so what is the dimensions? So dimensions array is p. So p0, p1, p2, p3, p4. This is the first dimension, that is 5. Then here a1 multiple with a2, right? So 5 into 6 is 6 into 2. So 6 is common here. So take 6 here. This is 2 is common, right? So write 2 here. Here 4 is common. Write 4 here. Finally, write the final value right here. So this is P0, P1, P2, P3, P4 value. Okay. Okay. In general, if matrix A has dimension Pi minus 1 into Pi. Clear? So what is MCM? So matrix multiplication is associative. Different ways of parentheses the same chain give the same final matrix but different cast. We choose the parenthesization with minimum number of scalar multiplication. Here we have 4 matrices are there. So many possibilities are there to perform the multiplication among these matrices, right? First we calculate the value of a1, a2, then a3, a4, then multiple these two values. This is one possibility. Otherwise, you find this two value, right? So many possibilities are there. First we find this two value and multiple with this value and multiple this answer with this value. So many parenthesization is possible, many splitting is possible to multiple the chain of matrix, right? So which one is give the best result? Best result means here the minimum number of scalar multiplication. That is the best way to multiply the chain of matrices, right? So in DP method is used to find the which parentheses give the which split of give the minimum number of scalar multiplication. Clear? So why dynamic programming here? Many subproblems repeat again and again, right? So example, in cast of multiplying a2, a3 is needed in different ways, right? So DP stores the solution of smaller subproblems and reuse them. Instead of recomputing, we look up the table. So we split the problems into the complex problem into smaller one and find the solution of each subproblems and stored all the result in the DP table, dynamic programming table. Then future we use that calculated values for the better result, for the optimized solution. Okay, clear? So this is the formula to calculate the matrix chain multiplication using DP method. So here Mij means matrix I, matrix J. So minimum number of scalar multiplication. M of Ij means minimum of matrix Ai multiple with matrix Aj. So we try every possible split point K between I and J. This is the formula to fill the value used to fill the values in the table, DP, dynamic programming table. So minimum number of scalar multiplication of I and J, the matrix I and J equal to minimum of I less than or equal to K less than J, M of I K plus M of K plus 1J. Then add these dimensions Pi minus 1 into Pk into Pj, right? So these values are already here, right? So these are the So these are the values. So we get this value from the given data. Alright? Clear. So the base case is M of Ia means. So Ia means multiple the same matrix. A1 with A1, the cast is 0 because we cannot multiple the same matrix again because the one important rule is there in matrix multiplication, right? So what is the rule? The row of the column number of first matrix is matched with the row number of second matrix, right? So in the matrix multiple with the same matrix mean violate that rule, right? So don't multiply the same a1 a2 a2 a1 a1 a2 a2 a3 a3. We cannot perform the multiplication in the same matrix. So the base case is 0 here. Okay, cast of single matrix is 0. Okay, so this is the problem. So 4 matrices are there and given their dimensions also. This A1 matrix, the first matrix contains 5 row and 6 column. Here 6 row 2 column, 2 row 4 column, and finally 4 row and 3 column. Then perform the matrix multiplication like A1 into A2 into A3 into A4, right? We can perform because these two values equal, right? The column number of first matrix match with the row number of second matrix. Here also the column number of first matrix match with the row number of second matrix. Here also the same case is there. So we can multiply all those matrices one by one. That is called a chain multiplication. Okay, these are the many parentheses are there. Many ways are there to find the final result. But which one give the minimum number of scalar, which one need minimum number of scalar multiplication? We choose that parenthesis, that split up method. Right? So the DP programming, the DP method used to find the minimum scalar multiplication parenthesis. Which one is best? Okay. So matrices are there. So then compare with the normal multiplication. So now how will perform the normal multiplication? Left to right, right? So initially we multiply A1. So our problem is say A1 into A2 into A2 into A4. So this is the scalar multiplication. So matrix chain multiplication, right? A1 into A2. So A1, A2, A3, so A4. This is matrix chain multiplication. What is the normal method? First we multiply A1 with A2, right? Then that resultant matrix multiple with A3. Then that resultant matrix multiple with A4. This is the normal procedure, right? Then check how much the total cost is, how much the scalar multiplication need to perform the normal multiplication. So this is the dimension of A1, this is dimension of A2. Then how to find the number of scalar multiplication, that means cost here. Then this is common here, this is common. Just simply write 5 into 6 into 2, that is 60. This is the scalar multiplication. So we need 60 number of scalar multiplication to perform the A1 into A2. So here what is this? This is resultant matrix. So after we calculate this value A1, after multiple A1 and A2, the resultant matrix have the dimension 5 into 2, right? So here cancel these two values. The resultant matrix have the dimension 5 into 2. Clear? This is the dimension of resultant matrix. Then this matrix multiple with the third matrix, right? This matrix multiple with third one. Then find the cost. This A3 dimension is 2 into 4. Then find the cost. Take 2 as common one. 5 into 2 into 4. Number of scalar multiplication need here 4. The resultant matrix dimension is 5 into 4. Simply cut this value. 5 into 4 is the resultant matrix value. Then this matrix is multiple with the next matrix, that is A4. This is normal multiplication procedure, right? Then this is the dimension of these two matrices. One is resultant matrix and this is A4. Then find the number of scalar multiplications there. 5 into 4 into 3. 4 is common in both the dimensions. So write it one time. So 4 into 3, this is total number of scalar multiplication. This is the resultant matrix. So the total number of scalar multiplication is 60 plus 40 plus 60, 160. So but here we are using DP method. We find this parenthesis is best to give the minimum number of scalar multiplication. So we first we find the A1 and A2, then A3 and A4, then finally multiply these two matrices. This is best. Find this, choose this using the DP method. Just justify this result. Here A1 and A2, the scalar cost is 60. Okay, 5 into 6 into 2, that is 60. Resultant matrix is 5 into 2. Okay, we cancel these two, this row and this column value, column and row value. Then this is the resultant matrix dimension. So 5 into 2. How to find the resultant matrix dimension is likewise. We multiply this matrix with this matrix, means we get one result, right? In matrix format, that matrix contain the dimension 5 into 2. Just cut this common value, this column and row value. What is the remaining value is there? 5 into 2. So this is the dimension of resultant matrix. Clear? This is the dimension of resultant matrix. Okay. Then this resultant matrix, then find the A3 and A4. Then this is the resultant matrix of this. Then multiply these two values, these two matrices. Then cast is 30. This is the resultant matrix. Then simply add all the cast, that is number of scalar multiplication. This is 114. This is better than all other parentheses. Clear? Okay, many possibilities there to find the matrix multiplication. So which one give the minimum cost? Which one give the better result? So okay, in first step, initialization. So the table is there. Okay, here 4 matrices are there. We perform A1 into A2 into A3 into A4, right? 4 matrices are there. So we first design one table for into dimension 4 into 4. Number of row and number of column equal to 4, right? So this is the table. Now how to fill the value? This is called dynamic programming table. So this is the matrices, right? So and how to fill the diagonal values are 0. We already discussed in the formula, right? M of II equal to 0. This is the base case. Minimum number of scalar multiplication of the same matrix. M of IA. That means M of 1, 1, M of 2, 2, M of 3, 3. So that are appeared in the diagonals only, right? So put that value 0. We cannot multiply this same matrices because we can, this is not satisfy the matrix multiplication rule. What is the rule of matrix multiplication? The column of first matrix match with the row of second matrix. But here, so the rule does not follow here, right? So we cannot multiply these all items. So simply put 0 in diagonal. Clear? This step over. Then this is second step. In this step, we need to fill this value. Need to fill this value. Okay, we fill step by step in diagonal manner. So in this step we need to fill this value. Here the chain length is 2, right? Chain length 2 means we need to calculate the multiplication of two matrices. Here what is the intersection? 1, 2, right? M1, 2 and M2, 3 and M3, 4. That means multiple matrix 1 with matrix 2, multiple here matrix 2 with matrix 3, here matrix 3 with matrix 4. So the total number of matrix in every multiplication is 2. This is chain length, A1 into A2. Likewise, okay. Then find the number of scalar multiplication need. How to calculate? So the here A1 into A2. So M of 1, 2 means A of 1 is multiple with A of 2, right? A of 1 multiple with A of 2. Then check the dimension of these two matrices. A1 is 5, 6, right? A2 is 6, 2. What is the scalar? How to find the scalar multiplication? 5 into this common value, right? So write one time. So 5 into that common value, that 6 into then 2, right? Then so what is 5 into 6? 30, 30 into 2, 60. This is scalar multiplication of first two matrices. Then find matrix 2 and 3. So here what is matrix A2? This is matrix A3. Then how to find the scalar multiplication? 6 into, here what is the common value here? 2, 2, right? So 2 into 4, right? 2 into 4. So the value is 48, right? Then here 3 with 4. So 3 here 4. So value is 2 into common value 4. 2 into 4 into 3. So likewise we find the number of scalar multiplication need for every matrix chain multiplications. Clear? So likewise we find the value and fill it in the table. Clear? Otherwise you use this formula. So this formula also give the same result. Okay, simply directly multiple the dimensions and calculate the scalar multiplications. Otherwise, number of scalar multiplication. Otherwise, use this table. Okay, so minimum of 5. Here k means k initially. What is the k? Here 1 2. So no k value is 0 here. So initially k is 0. So we don't split any matrix like 1 2 2 3. The continuous matrices are there, right? So here the k value is 0. So we substitute that value here and find the what is the I less than or equal to k less than j here. I less than or equal to k. So here find m of ij. Here means m 1 2, right? 1 2 means 1 less than or equal to k and less than or equal to and 2. So what is the k value here? Less than j. So less than j means less than j. So what is the j value here? That j value is 2, right? For this cell. Okay, in 60. Ij is 1 and 2. So what is the k value here? K is 1 less than or equal to k less than 2. So what is the k value here? The k value is 1 here, right? Sorry, not 0. The k value is 1 here. Based on this condition, we take the k value, right? 1 less than or equal to k less than 2. So less than 1 less than or equal to k, right? So the k value is 1 here. So substitute k value here and corresponding I value here, right? J value here. What is p I minus 1 pk pj? So already write from the given data, right? So p I minus 1 means I minus 1 here 1 minus 1 that is 0. P 0 value that is 5 into, so initially these values are 0, right? The same matrix value, so these are 0, right? Then here only take this value. So pi minus 1 5 into, so pk, so that is 6 into pj, that is 2. Like this, you directly multiply these two values here. Okay, both are give the same result. Clear? Using this formula, directly calculate the number of scalar multiplication and fill it in the corresponding diagonal cells. Okay. Then next we need to fill these two values. So need to fill these two values. So the 60, 48, 60, 40, 24 already filled. So in previous step, right? So we need to fill these two cells in this step. So what is the array value here? M1, M3, right? We need to calculate M1. So what is the intermediate value? 2. So M1, 2, 3. So length of the matrix is 3. So chain length equal to 3. So M1, 3 means, so M1, 3 means, so multiple A1, A1 and A2 and A3, right? So the chain length is 3. Here we multiply 3 matrices. And what are the possibilities are there? Here 2 possibilities are there. First we calculate these, multiply these two matrices and resultant matrix with this matrix. Otherwise, one more possibility is there. So we find this result first, then multiple with this value. Right? So these two possibilities there. So here we use two k value. One is k1, k2. K1 means we split the array, A1 array first. So first A1 is there. Then we then 2, 3 is there. So we perform first this part, then multiple with 1. First matrix. Here K2 means we split the matrices, a matrix chain in k value 2. K value 2 means we split the matrix like K2, right? So A2. So we perform this calculation first, then the resultant matrix with A3. Okay. So this is K1, K2. K2 may, K1 to and represent the split up of the matrix chain. Okay. Represent the split up of matrix chain. Clear? Okay. So directly substitute all the values in the formula, otherwise you manually fill the table. Okay, here. Okay, initially M13. So we need to perform matrix chain multiplication among three matrices A1, A2, A3. Then only the chain length called 3. So here two possibilities there, K1, K2. K1 means we split the array here. K2 means we split the array in this position. Okay, two more possibilities there. So we split the array here means we perform this first and next multiple this resultant matrix with A1. Clear? Okay, if you take K2 means split the array in this part K2 and first we perform A1 with A2 multiplication and this resultant matrix multiple with A3. Okay, two possibilities there. Okay, perform first this, manually fill the value. So we take this value from the table. What is the value of A2, A3? This is 2, this is 3, right? What is the value of A2, A3? That is 48. Okay, 48 is there from the table data. Then number of scalar multiplication of A1 into A2, A3. How to find this? So what is the matrix of A1 matrix dimension? 5 into 6. So already given in the. So this is A1 matrix dimension. What is the dimension of A2, A3 resultant matrix, right? What is the dimension of resultant matrix? What is the A2? A2 6 into 2. A3 that is 2 into 4. Then resultant matrix is simply cut these two values. The resultant matrix is 6 into 4, right? So just like here. 6 into 4. Okay. Then how to find the scalar multiplication? Then write the common value one time. So multiple with all values. 5 into 6 into 4. Right, then 120, then add these two values, that's table data with this new calculated values. 48 plus 120 68, right? Then find one more value, that is K2. So which way is best? So which one give the minimum, which one need minimum number of scalar multiplication? We take that value and fill it in the table, right? So one possibility is over and find one more possibility. A2, A3, A1, A2 and A3. So A1, A2, the value take from the table, that is 100. That value is there, that is 100, right? Yes. Sorry, that value is A1, A2 value. A1 here, A2 here, the value is 60. So 60 plus, then find the number of scalar multiplications. Scalar multiplication of this matrix. So A1, A2, what is the resultant matrix dimension? A1 5 into 6, 6 into 2, so 5 into 2. The resultant matrix is 5 into 2. Then what is the A3 matrix dimension? That is 2 into 4. So 5 into 2, 2 into 4, the 2 is common, so write one time, 5 into 2 into 4. That is 40. The total number of scalar multiplication is 100. So which one is minimum? Here 168. Here 100. Which one is minimum? 100 is minimum. So we fill with this value. Clear? So here we are using the formula and calculate the values. And which one is minimum? You choose this value and fill it in the table, right? This is we manually find or using the table. Using this formula, right? So both are valid. Both are give the same result. Okay, this is the manual method, how to find the number of scalar multiplications, and here is the formula method is there, right? So next we need to calculate this value. So already 100 over, so we need to calculate this value. The same procedure here. Here what is the value? M2, M4. So we perform the matrix multiplication of matrix chain multiplication of A2, A3, A4. Okay, A2, A3, A4. So here also two possibilities there. So initially K is 2, the split here. So find the A2, A3, A4 and then multiple with this A2. Right, one more possibility is split this matrix in K3, K equal to 3. So split here. And then perform this first, then this resultant matrix multiple with A4. Okay, so which one is give the minimum number of multiplications? We fill that value in the table. Okay, likewise the same procedures. So these values pick from the table data. A3, A4, what is the value? 3, 4 the value is 24, right? If the value is 24 plus, then what is the then find the number of scalar multiplication need to perform this matrix, this way of matrix multiplication. So find the A2 matrix. A2 is 6 into 2. Then A3 into A4. A3 into A4, the resultant matrix is, cut these two value, resultant matrix is 2 into 3, right? 2 into 3. Then how to find the matrix number of scalar multiplication? 6 into 2 is common, right? So simply write one time, 6 into 2 into 3. Then add both the values. Take the value 60. And likewise we find this value also. Okay. So if both values are combined within the one common bracket, so we pick that value from the table. Okay, don't worry about this. So here this is the two matrix contained in one bracket, right? So take this value from the table. Here this value take from the table 2 3 m2 m23, here m34. Then find the number of scalar multiplication, add both the values. Then which value is minimum, fill that value in the table. Okay, now 160 is over. Then in final step we need to calculate this final cell here, the final value here, right? Okay, then here chain length is 4 because the value is 1 into 4, right? So we need to multiply the, so we reach the final step, A1 into 2 into 3 into 4. So what are the possibilities are there? We split the matrix chain like K1, K2, K3. So K1 means split here, right? Split here. A2 means split after A2. K3 means split after A3. And so these are the three possibilities are there. Then find the same. So using this formula, manually fill these values. Okay. So pick this value from the table, right? 2, 3 here. Then A12 value take from the table, A34 from the table data. Clear? In A2, A3, A4, here what is the value? 60, 1, 2. Right? Then perform the 5 into 6 into 3. So A1 matrix dimension 5 into 6. A2 dimension matrix 6 into 2. Okay, and 23. They simply use this formula or manually fill those all details in the splitter. Clear? One, 2. What is the value of 1, 2? That is 60. Here we know 1, 2 and 3, 4. Here what is the value of 1, 3? So that is 100. That is 100. 1, 3. That is 100. Okay. Here 1 with 2. 1, 2. Here 1, 3. Okay. 1, 2, 1, 3. Okay. So using the formulas. So both the methods are valid. Okay. Finally we fill this cell also. That value is 1 on 4. Right. So this is the final M table, minimum number of multiplications. So that is the minimum value is, minimum number of scalar multiplication is 1, 1, 4. Then optimal parenthesization is A1 into A2 and A3 into A4. This is the simplest method. Clear? Clear? Okay. So this is very simple concept. So in many we want to multiple more matrices one by one, means we find which one is the best way to find the result. So which one need the minimum number of scalar multiplication. So using DP, dynamic programming method, we calculate the minimum number of multiplications. Clear? Okay. So which one give the best solution, minimum solution? Here 114. This one give the this split up give the minimum solution, right? This split up. So this is the best ways to split the matrix and perform the multiplication. A1, A2 and A3, A4. Okay, this one give the minimum number of multiplication 114. So choose this parenthesis as a final result. Final way. Clear? Thank you.